I think I'm here primarily to bring down the average education level on the panel. We've got 2 doctors. I think I'm bringing it down by like 6 years, so we're going to be okay here. I'll start out just tell you a little bit about No One Seems to Know Who Salt River Project is. I've got a little video here to kind of let you know that. They can say it better than I can.
Meeting the needs of our electric customers and water shareholders is always the right idea at SRP. For more than a century, we have been dedicated to providing reliable, reasonably priced water and power services to meet the needs of people, businesses, and communities in Arizona. As one of the nation's largest public power utilities, we provide generation, transmission, and distribution services to about 930,000 homes and businesses in our service area. We also are the largest water supplier in the Greater Phoenix metropolitan area, with a service area covering more than 375 square miles and management responsibilities for a 13,000 square mile watershed. SRP is a leader in the community, anticipating, planning, and implementing strategies that make the most of Arizona's precious resources, meeting the needs of our power customers and water shareholders now and in the future.
All right, so that's who we are as a company. What we're going to talk about today is Coronado Generating Station, our operator training simulator, among other types of simulation. We're actually a coal-fired plant, and we've added on through the years probably every type of environmental control that's commercially available. Historically, our control room operator training was just a 2-week classroom. We had 18 JPMs that were performed in the field. The unfortunate thing about that is you have a job performance measure, which is a good thing to do. However, those events didn't always happen, thankfully. So usually we did it with thought experiments and just kind of talking through events. And then they had to be upgraded on the units for 80 hours before they were turned loose. About 2009 is when we started working on the simulator. We actually had it installed by 2011. It was included as part of a DCS migration project. We went from a TDC 3000 to an IA system. We justified the simulator that way in that we knew we had several things happening. We were losing 90% of our workforce to retirements. Also, just having new controls kind of pushed it forward. So with simulation, as Rick mentioned, most of the realism happens actually with the process variables that are manipulated by a model, which is just a mathematical representation of the unit, of course done with a nice pretty little GUI. We added a little bit more to ours. One thing we did, we actually mimicked our control room environment, so it looks like a control room. Same type of console, same number of screens, everything. We also actually added an actual I/O interface so that we could also do some maintenance training and configure our scanners, that kind of thing. Also, just to have fun with. The thing that I started recognizing as newer and younger people started coming in and training was that as the newer generation comes in, they started treating it like a video game. And it is kind of like a video game. I mean, it's essentially, at the core of it, is the same technology. So I needed a way to just basically scare the hell out of them and make it to where we could make them take it seriously. So it came from, this was just a fun little project that we did, a little air tank that ties in. If they trip the unit, the air releases. It also, if they get into issues like with our deaerator and loose pressure, it'll slam that little piston into that bucket, and it's just fun and fireworks. So during our migration, we did 4 days of training for existing supervisors and operations specialists. Our claim to fame there was we actually had no startup delays due to operator error and no startup delays due to DCS logic, which was our side benefit. Was that we found multiple control issues that we thought were found during the FAT, where when we actually connected them to a high fidelity model, we found that we weren't nearly as robust as we thought we were. We found upwards of 200 control errors that would have bit us had we not done it. Currently, our OSD training program, that's just Operations Specialist Trainee is what it stands for, people trained to be control room operators. We have a 120-hour Operations Specialist school, We actually do it with the simulator, so we do a little bit of classroom, and then we actually have them demonstrate on the simulation. The CBTs that we have them do during the training just kind of keeps us on track. So, and it's a 6-week program. So this is what we were facing, and this is actually information from 2015. It's gotten worse since. Our average years experience in control room, we went very quickly from about 16 to 18 years down to currently, this actually went down even further. This is from last year. We're down under 2 years of average experience in our control room currently. So that's a trial by fire, right? So this is like, this simulation is going to work. We're going to be able to train these guys on how to drive these units, or we're going to fail spectacularly. Luckily for us, I mean, now 90% of our control room did actually come through the simulation program. There has been an observable increase in knowledge and confidence that we see from what we compared previously to trainees and what we're seeing today. It always was in the past that we could take a new operator, pair them with a seasoned operator, and so they could kind of lean on him and teach him as events came up or excursions. Those days are gone. We don't have those people anymore that can do that. Also, as the market changes and things in our industry are changing with our loading profiles, new problems start arising. So another thing we've seen from the simulation is just finding, ways to mitigate those problems. And this is basically the fear that we were facing at the time. If you could play this.
Huh? Noise! Bad noise!
5 minutes before critical mass.
Critical what? Okay, don't panic. Whatever problem this is, I'm sure they know how to handle it. Oh? Ah! It's my problem! We're doomed!
Sector 7G is now being isolated.
Mr. Burns, people are calling this a meltdown.
Oh, meltdown. It's one of those annoying buzzwords. We prefer to call it an unrequested fission surplus.
Homie, please be all right.
Gotta think. Okay, somewhere there's a thingy that tells you how to work this stuff. The manual. The manual, right. Ah! It's as bad as a phone book. Congratulations on your purchase of a Fissionator 1952 slow fission reactor. Don't get to the point, man! Woo, what's this? Don't! Who'd have thought a nuclear reactor would be so complicated?
So yeah, that's what we expected. Now, luckily for us, that didn't happen. This is actually a trend or a bar graph of our operator error-related trips since 1975. We've actually kept track of that. And you can see tailing off there towards the end, we've actually gotten slightly better. We're not any worse off there than we ever were. So a lot of getting that is not only the initial training, it's also trying to build an environment where we have a continuous training. So anything that happens with on our units, we see any operator error, we see any process differences that are happening that we need to teach people on, we always rotate them through and test things on the simulation. It's always available 24/7, so an operator, when he's going into an unknown event or he knows something's coming up, he can run back and test and try it on the simulator itself. Along with that, one thing that happened, it was a corporate goal. They wanted to start actually, something in the fossil industry, we're not required to vet our operators. They don't have to qualify. It's really up to us when we say that they're ready. But we actually wanted to do a little bit better and actually make our operators go through a yearly qualification. And this is essentially how we did that with a trainee performance monitor. And this way it's empirical. It's not just up to the instructor. It's actually graded based on algorithms moving and monitoring certain parameters. So this is essentially what we do. We take them from a cold metal, from the very bottom, have them work up. It works through 11 tests as they bring the unit up. One of our big challenges, is the problem when you're trying to build an automated grading system is there's so many different things that can happen when you're dealing with upwards of 12,000 I/O points. That is getting things in there. You don't want to make it so hard to where nobody's going to pass, but you also don't want to make it so easy to where they're just cruising through it. So we did have to, it took quite some time building logic to actually drive grading and switch in various parameters based on the conditions of the time. And then, so we spend one day doing that, just a cold metal, and then the next day we'll review anything that happened over the past year that was operator error related or a unique situation or anything that we have coming up if we're commissioning a new system or something like that. And this is just a view of kind of what we watch as that happens. So I thought this was interesting. I had to throw this in because being from a younger generation, I was always faced with, you're this young guy, you don't have all this experience, you know, what could you know? So one of the interesting things that happened, I started watching this, was as we started going through yearly qualifiers, I found that, you know, experience did not mean that people were going to do better on grading. And it's not just because they're sitting in front of a computer and they're not used to it. Experience actually isn't everything in this. A lot of it is the quality of training, obviously, but obviously also how much the person takes it seriously, how much they're willing to learn, and then the whole thing. So actually, we got years of experience on a bar there. The red is actually the average scores, and we started tailing off towards the end. Now, to be fair, you know, some of the older guys may not, you know, take it. They're not as nervous about it as others because they know we're not going to kick them out of there, right, if they don't do great on the tests. So. Something that's happened, this is very recent. This is a new challenge that we're facing, something that the simulation has really been paying dividends for us. These are our load profiles. We have 2 units there. So this is 12 days of load, 2013 versus 2017. So 2013 is 12 days in December. I wanted something recent. That trend on the top, that's it. We were base loaded just constantly. Oh, sorry. So we were base loaded constantly. So basically what we would do is we would bring these units up, we would take them to as much load as we could possibly produce, and then we would just tune and try to make them as efficient as possible. Those days are completely gone to us at this point. Even in the summer when our loads are highest, our load profile looks more like that bottom trend. And what you're seeing there is one unit coming offline and the other unit swinging from essentially almost our minimum up to base load, sometimes several times a day. This opens up a whole new world of challenges for us that we're not used to with thermal cycling and things start breaking. Something that's also done is it's changed how we operate. So we had to come up with new procedures for almost everything that we do on a daily basis. And that's where the simulation really has worked out for us because we can practice over and over again. And the robustness of our models is close enough that we can actually see those things happen in the real world after we test them on the simulation. Going into the future, it's all about just trying to get better. Mostly, we're changing the grading algorithms. We're trying to make those more proficient for the operators to where we're testing them on more actual events that they're actually seeing. Also improving the models to do more with engineering studies and heat rate analysis and those sorts of things. Another thing that's happening is more of our sites continue to add simulation systems. So we've started looking into, and we've done a few tests with doing group training on a corporate-wide scale. That way we can include dispatch and actual frequency excursions and those sort of things that we see on the grid. That's all I've got.